So this topic that we're going to move on to and look at is still doing with the energy, with ideas of energy. It's about the concepts of heating and cooling, which you may remember that if we think about the sort of energy, if we think about the energy transfers that we listed, mechanical, that's doing things by applying a force. We have had electrical. We've had sort of radiation, light, and sound. And this final one that we're looking at is the concept of via heating. Okay, so we've had a look at these other ones. We've gone off into some other different little bits, but this is the final kind of energy transfer method that we're going to look at. Okay, and it's commonly referred with things either getting hotter or getting cold because of this idea of things being moved. I think thermal energy stores moved around via heating. So, just as a kind of an introduction, there's probably something that hopefully you are aware. Okay, if you leave sort of a cup, I'm going to colour in red, even though eventually we'll. If we leave a cup of tea, I need a thicker pen for this. Let's leave a cup of tea on the side. What happens when we come back and time passes? Well, you will probably, unsurprisingly, recognize the duplicate that. Copy it, and then hopefully paste. Excellent. Oh, I can do it. It's exciting. You probably noticed it when you come back later. That was an utterly needless sort of diversion into my attempt at closing. But you'll come back later and you'll find your tea is now cold. Okay. The reverse. Okay, physics. Many things in physics are reversible, but that way, that doesn't happen. You never start with something cold, go away. You never start with a cold cup of tea, go away, come back later, and find your tea is suddenly nice, hot, able to drink. Okay, and that is because there is a thing at play here, which formally is called the second. You never need to remember this, but it's called the second law of thermodynamics. Okay, so you can know the second law of thermodynamics, which is thermo meaning heat, dyno meaning movement. So it's about this is one of the principles behind engines and refrigeration units and all these other kind of things, which is that heat or thermal energy will always flow from hot things to cold things, and this is kind of a rule that happens in physics. So you never need to know it's called the second law of thermodynamics, but the idea is something that should make sense, which is the thermal energy will naturally flow from hot objects to cold ones. And sort of the hotness of an object is measured by its temperature. So this means essentially this is from a high temperature to a low one. And if we considered sort of this case here, we have our tea, which might be sort of something, like it's sort of, let's imagine that's at 85 degrees Celsius. You have a room that might be at around about 20 degrees Celsius. And so what that means is that thermal energy is going to come out of the tea into the room until one of two things occurs. Either either the tea, most likely the tea is going to cool down to 20 degrees, or if this is a super large cup of tea and you have a really tiny room for no apparent reason, the tea might warm the room up until they reach some kind of higher temperature. But fundamentally, this is how things work. Eventually, after some time later, everything is going to be at the same temperature. And given it's probably a big room, the energy that's in the tea is unlikely to change the temperature of the room, so you'll probably end up with around still about 20 degrees C. If you brought in a million teacups and left them to cool down the room, maybe you'll get this room eventually ending up at about 22 degrees, and that's where everything will end up. But that's just a massive waste of tea as far as I'm concerned. So this is a critical sort of idea. If you're ever thinking, where's the energy going? It's going to go from a hot object to a cold one. If you ever want to reverse this flow, so if so refrigeration, so fridges and freezers and things where we want the opposite to occur, we want to have essentially a box with ice in it, then you have to put energy in, and that's why your fridge is connected up to the mains. That's the thing that's keeping that by putting energy in, we can lower temperatures below certain things, but it's not free. If you feel around the back of a fridge, you'll notice that it's actually quite warm at around the back of a fridge, because actually you're taking heat from inside the box, and your thermal energy from inside the box, and you're taking it outside of the box in that kind of way. So there are strictly, I'd go with there's probably 4, but for the GCSE there are 3 methods of the way heating can occur. So there are 3 main methods via which heating can occur. And let's read them. Okay, they're ones you may remember meeting back in year 8. But you have conduction, convection, and radiation. So conduction, convection, radiation. The other one, if you are interested in it, is you can have things. You can have it occur by evaporation. So, which is one of the reasons why, if you've got a travel cup, you tend to have a lid. The coffee that you get from a takeaway coffee, and that's to stop thermal energy being lost by evaporation and losing stuff to steam. Equally, it's also why if you want to cool something down that's hot, you blow on it to increase evaporation to make sure that you get more evaporation. But that doesn't really come into the GCSE, so you don't need to worry about that. You'll also probably notice that this term radiation is also sort of up here. So we had radiation via light and sound, and that's because there is an overlap. You'll remember, if you remember it, this kind of radiation where we have it by heating has a special name. It's sort of like mostly via a thing called, it's the infrared radiation. Okay, so there is an overlap between them, because actually one of the things about these, we're trying to sort of like divide up, a lot of these physical processes, but some of them are actually sometimes, very similar, or there's overlaps between them. So be aware that sometimes when you talk about radiation, you can talk about radiation, which is a method of heating, or you can be talking about radiation involving, say, light and sound and other bits of the EM spectrum. In the topic of heating, when the term radiation is used, it predominantly refers to infrared radiation, but many of the properties are the same. Okay, so what we're going to do over the next few lessons is we're going to see some demonstrations of conduction and convection radiation, and talk about some of the phenomena at play. And we're going to start with conduction. Okay, So it was a bit of, hopefully a bit of a reminder, or you might be familiar with this idea. So conduction is the method of heat transfer, method of heating. That mainly occurs in solids. Okay, and what will happen is where energy is passed down through the vibrations of particles in the solid. So if you think about how we might draw some solids, solids are sort of nice, regularly arranged, and this is where I'm always going to wonder how many particles should I draw. Okay, so if we have a series of particles, and what we can remember is that particles, they can just vibrate a little bit. They sort of get to move. So they are constantly bumping into lightly their neighbours. So they are sort of like pushing against their neighbours. If we increase the temperature, so we sort of like if we add some energy to this particle, then this singular particle is now going to move around a bit more. Let's see if I can actually catch that one particle on its own. Yeah, so normally it's sort of bumping around sort of lightly, but if I add energy to it, if I make it hotter, well, what's going to happen is it's going to vibrate more, okay, with more energy. But what that is going to do is going to pass on energy to its neighbour, which will then vibrate more, and so suddenly catch them both. Nope, doesn't want to let me catch them both. Yes, now they're both vibrating sort of more and more and more. And then what that will happen is they will pass on their energy to their neighbours. So I've now got lots of things vibrating more and more and more and more. And so what will happen is that slowly, or fast, depending on what the material is, these vibrations get passed from one end to the other. So we get eventually hitting a point where all these particles are vibrating at the same, and at the same rate. Okay, so as particles vibrate, note, particles gain energy. They vibrate more. Giving to their neighbours. And that's the principle, really, of conduction. And any solid, well, all solids can conduct. But not all solids, as we'll look in a certain few experiments now, will conduct in the same way. So at this point, you can now watch the next video, which is all about some demonstrations to enjoy.